Find the exact value of cosine of alpha plus beta if the cosine of alpha is 7/15 and alpha is in quadrant number 4, and the sine of beta is minus 1/3 with beta being in quadrant 3. Well, we're asked to find the exact value of cosine of alpha plus beta. So we're going to think about using our sum formula for cosine. So cosine alpha, cosine beta, minus the sine of alpha, sine beta. And if I'm looking up above, well, I already have some of the values, right? I know a value for the cosine of alpha, but I don't know cosine beta. And I don't know the value for sine of alpha, but I know that sine of beta is minus 1/3. So if I can just find cosine beta and sine of alpha, I'll be all right. So I'm going to use this given information to do that. And what I'm going to do is start by drawing a reference triangle. So instead of having angle alpha in it, it'll have the reference angle in it, alpha bar. That positive acute angle in the first quadrant where the trig functions have the same value except for maybe the sines. I know that cosine is the adjacent over the hypotenuse. And so now all I have to do is find the missing side. So I have 15 squared is equal to the missing side squared plus 49. All right, let's see, that's 225 is equal to question mark squared plus 49. Take 49 away from both sides. All right, so I need to subtract 49 from 225. And you know, if I was less distracted today, I think I could do that in my head. But 225 minus 49 is about 176, except for the about. It's exactly 176. So the missing side is the square root of 176. Well, if I look at what 176 is the same as, it's actually 16 times 11. And we can check that really quick. I have 176 divided by 16 is 11. And so that missing side is 4 root 11. All right, well that will let me find the exact value of the sine of alpha. So with all of that, the sine of alpha has to be 4 root 11 over 15. But being in quadrant 4, I know sine is negative. All right, well, I can plug that in where the sine of alpha goes. So where that set of parentheses was, I can write minus 4 root 11 all over 15. Neaten that up a little bit. All right, I'm going to do the same thing for beta. Draw a little reference triangle with the reference angle beta bar in it. And now I can think that sine is the opposite over the hypotenuse. And I'm just using positives here, right? Because I'm thinking about a reference triangle. I'll get the sign right in a moment by knowing that beta is in quadrant number 3. Again, I'm looking for a missing side, so I'd have 9 is equal to the missing side squared plus 1. And so I get the square root of 8, but we know we're going to write that as 2 times the square root of 2. And I'm really looking for the cosine of beta. And so from that triangle, I know the cosine of beta would be the adjacent over the hypotenuse, 2 root 2 over 3. But I need to think that beta is in quadrant 3 where cosine is a negative value. So let's see here. I have minus 2 root 2 over 3. Well, I can tell that my common denominator is going to be 45. I have minus 14 root 2 plus, well, let's see, minus a negative, 3 negatives in a row here. So a minus a negative times a negative. So that's actually going to be a minus 4 root 11. All right, we found our exact value. It's not very pretty, but that's it. And that's it for now.